Hi friends, now we're going to keep on going here, and we're going to get some of our first theorems here in Chapter 2. Now here's a few things. These numbers on the side, they don't mean much except for that's what's found in your book. What's more important is if they have a name and what's after it, kind of like with postulates. We didn't memorize postulate 1-1. We memorized that if we have any 2 points, they determine a line. That's the type of stuff I need you to understand. So this one has a name, so it's going to be very important. The first one's called the vertical angle theorem. And I call it that it is a very much, and you can abbreviate for angle, theorem. And you can actually put TH for theorem too. I'm pretty okay with that. Now here, it's one of those fundamental theorems we used over and over again. So firework it, put, muy, oops, I put a Y there. We'll respell that. Muy important. Make sure it means very important, by the way. Here's the first one. It says, if two angles are vertical, then they are congruent. So remember, when we have two lines intersecting, we have two vertical angle pairs. We had 1 and 2, 3 and 4. Now let's think about how common sense this really is. When I work with it and I have a linear pair, let's say angle 1 was 100 degrees. So if angle 1 was 100 degrees, what did that make angle 3 if they're a linear pair? Well, they add up to 180, so this one's 80. Well, if angle 1 is 100 degrees, angle 1 and angle 4 are still considered a linear pair, and that meant angle 4 was 80 degrees. Look at this. Angles with the same measure are what to each other? Congruent. Well, that also means I could solve for angle 2 and show that it's congruent to angle 1. So my vertical angle pairs are congruent. And why is this? Because of the angles being supplementary, because they're a linear pair. So that's really because they're being supplementary and because of adjacent angles. So this is actually critical, and we're going to always get to the point where we start looking for this. Anytime you have two lines intersecting, you just start looking for vertical angles, because a lot of times that will help us. Now the next two theorems are very similar, and they're kind of common sense, but it's almost like two theorems in one because they didn't really want to rewrite it. But the first one's called the Congruent Supplements theorem. It's the following. If two angles are supplements of the same angle, or of congruent angles, so we're going to use our congruent symbol, then the two angles are congruent. Here's an example of our given statement. This is kind of using some of our logical reasoning. Angle 1 and angle 2 are supplementary. Angle 3 and angle 2 are supplementary. Therefore, this theorem tells me if they are supplementary to the same angle, they are congruent. Now, here's going to be the most popular question I ever ask you. Why? Well, the reason why, let's think about it. If I know the measure of angle 1 plus the measure of angle 2 equals 180, and I know the measure of angle 3 plus the measure of angle 2 is equal to 180, I can use algebra to set them equal to each other because they're both equal to 180. So I get the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. Now, I want to show that angle 1 and angle 3 are congruent. What can I subtract from both sides? That's right. I'm going to subtract the measure of angle 2 from both sides. So then I get the fact the measure of angle 1 equals the measure of angle 3. And if angles have the same measure, they're congruent. And that's because the definition of congruent angles. So it's kind of common sense how that works. Then we have our congruent complements theorem. The congruent complements theorem says if two angles are complements of the same angle or of congruent angles, then the two angles are congruent. Now this is exactly the same theorem as the last one, except for instead of, typo, big time, of adding up to 180, they add up to 90. So we're going to change this word to complements or it's going to drive me nuts. I'm definitely the typo queen. Now notice I chose to take a different approach this time. This time I'm going to state that angle 4 and angle 2 are the same, are congruent to each other. Now remember, this is this part here. or of congruent angles. So they're complementary to congruent angles. 4 and 2 might both be 40 degrees. Well, if they're both 40 degrees, that means that angle 1 and angle 3 both had to be 50 degrees. So therefore I know angle 1 is congruent to angle 3. Now just remember the example we used there. You know, let's just say angle 4, the measure of angle 4 equals 40, and the measure of angle 2 equals 40 because they're congruent. That automatically meant these were both 50. So therefore they're going to be congruent to each other. Now, the next one seems like the funniest little theorem to use, but it works amazingly all the time. And here it is. It's going to be earth-shattering. I know you're going to be surprised. All right angles are congruent. Now, why do we use this? To prove triangles congruent later. That's seriously, or lines parallel, is really why we use this. So all right angles are being congruent. So what can we assume? Here's an example of this. If I give you angle 1 and angle 2 are right angles, what can we automatically assume? Well, if they're right angles, therefore they're congruent to each other. So we can go angle 1 is congruent to angle 2. Now why is this? Because of their measures. If they're right angles, they both measure 90 degrees. Therefore, I then know the measure of angle 1 equals the measure of angle 2, which makes them congruent to each other. And then my favorite one is a really kind of common sense one about perpendicular lines and things. Now here's the first one. It says if two angles are congruent and are supplementary, then each is a right angle. Now think about that. If they're congruent and supplementary, that means the two angles have to add up to 180. Well, if they're congruent, that means they're the same size. So I can actually replace the angle 1 in for angle 2. And I get 2 times the measure of angle 1 equals 180. Well, the measure of angle 1 is 90. Well, if the measure of angle 1 is 90, so is the measure of angle 2. So it's just some basic algebra methods. All right, now I'm going to give you a quick break here with all these theorems, and then we're going to work our last bit of example problems.